Alrighty, how's it going, everybody? So today what we're going to do is we're going to be solving two variable systems of equations using substitution. Alrighty, so the first step it tells us over here is that we need to isolate the variable. In order to isolate the variable, what we need to go ahead and do is just get one of these x or y's by itself. It doesn't matter which, but I would venture to say out of these two equations, the second one down here, if I just subtract 5y to the other side, I'm going to get negative 9 minus, and here, actually what I'm going to do, I'm going to take the moment, I'm going to go ahead and make sure it's in black. So then I'm going to have x equals negative 9 minus 5y. And so as you can see, I've isolated the variable x is by itself. Now what I'm going to do, and just so that way everybody's aware, this was the red step right here, this was isolate it. What I'm then going to do is then plug this equation inside the second one, okay? Because it says for step 2, substitute the expression from step 1 into the other equation. So that means we're taking this guy right here and we're plugging him into this one, okay? Right there for x. So what it'll look like is 4 times negative 9 minus 5y plus 3y is equal to negative 2. And what you'll notice right away is we've now eliminated all the x's, okay? And this was the blue step right here. So I'll highlight this in blue. Okay, perfect. Now, the green step goes on to say that we need to isolate the variable in the resulting equation. So this is the resulting equation, okay? But we need to isolate y. So going back to this right here, we have to distribute this in, okay? And 4 times negative 9 is negative 36. 4 times negative 5 is negative 20y. And then we can add our 3y equals negative 2. Now, we can go ahead and combine like terms on the left-hand side. And so we have negative 36. And then we have negative 20y plus 3y. And I believe that gives us negative 17y. Alrighty. Now let's move this negative 36 to the other side by adding 36. And so I have negative 17y is equal to, now 36 minus 2, that's going to be 34. Okay? And now I got to divide by negative 17. So then I have y is equal to negative 2. Okay? So that's what y is, okay? Now, that is isolating it. So I'm going to go ahead and highlight this guy. We've isolated him. Now, the next step goes on to say that we need to substitute the result from step 3, that green part, into either of the original equations. Now, the OGs, the originals, are over here, okay? They're the first equations we started with. So let's go ahead, plug it in. And I think plugging it into the second one would be easier. So I'm going to have x plus 5 times negative 2 equals negative 9. So 5 times negative 2, that's going to give me x minus 10. It's equal to negative 9. And then I'm going to add 10 to the other side. And so I get x is equal to 1. Okay. Now that right there is going to be the gold. Okay. That was figuring out the result for substituting into the other equation. Now, this x and y, this right here actually makes up a coordinate point. This is our true solution, okay? So the actual solution that we're looking for, guys, is not those two separately, but we're looking for this. So the solution, and I know I'm kind of writing it off into this little bit right here, but bear with me. It's going to be 1 comma negative 2. And hopefully you can make that a little bit prettier on your end, on your notes. But boom. That is going to be the answer, okay? Now we can do this again for the second one. Let's start by going ahead and isolating one of the variables. So it looks like for the second equation, we can easily isolate this y. So for the second one, I'm going to go ahead and add, oh, didn't have my pencil going. I'm going to add 4x to the other side, so y equals 3 plus 4x, okay? And that right there is already isolated. That was easy. So this is the red step. Alrighty. Moving on, we're going to go ahead and then place this inside of the y, right? Because we solved for y, so we're plugging this in for y. So we have 12x minus 3 times 3 plus 4x is equal to negative 9, okay? Now, this right here, we've gone ahead and plugged this into the other equation. So this is that blue step, okay? And now let's go ahead and distribute. So we have negative 3 times 3, and then we have negative 3 times 4. So that gives me negative 9. Negative 3 times 4, like I said, is going to be negative 12x is equal to negative 9. Now, looking at this, we can see that there's some like terms on the left-hand side. 12x minus 12x, that's going to add to 0, leaving me with negative 9 equals negative 9. Now, is that a true statement? Is negative 9 equal to negative 9? Yes, it is. This is indeed a true statement. And so what we can go ahead and say is, since we have two numbers equal to each other and they're the same one, we say that this is infinite solutions. Okay? Infinite solutions. And we can just stop there. Okay? It's not going to be one intersection, it's going to be multiple intersections. So let's go ahead and take a look at the next one. Example number 3. So what we're going to go ahead and do is isolate one of the variables. So for this first equation, it looks like if I just subtract 5y to the other side, I'm going to end up with x is equal to negative 8 minus 5y. And that makes things pretty easy, right? That's going to isolate it. And so this is the red step. Okay, isolate it. Then we're going to go ahead and put this inside of the x value because we solved for x, so we're going to plug it into the second equation. So we have 3 times negative 8 minus 5y, okay, plus 15y is equal to 10. And that right there, that's our blue step. Okay, we've plugged it in. Now let's go ahead and simplify things. Let's go ahead and distribute the 3. So 3 times negative 8, that's negative 24. 3 times negative 5 is going to be negative 15y. And then we just add the rest. We got 15y equals 10. Now what you'll notice on the left-hand side, once again, it appears that theyese like terms, the y's, they're actually going to add up to 0. So we have negative 24 is equal to 10. Now, previously, just a second ago, we said negative 9 was equal to negative 9. And that's a true statement, because it is. But is negative 24 equal to 10? Is that a true statement? And the answer is no. That's not a true statement. And unfortunately, since that's not a true statement, we are going to actually have an answer that says that we have no solutions. Okay, so here's a good example of a no solutions problem. Alrighty, let's take a look at example 4. Now, you'll notice here there's some more applications of systems of equations, and this is actually going to be very helpful, okay, for word problems, because a lot of us, and specifically my class, we've really been trying to make sure that our equations are in the form mx plus b. They're in this one, right? We've really tried to make sure that we have them in that exact format so we can identify the y-intercept and the slope. However, there are instances, especially in word problems, where we're going to have to broaden our horizons, and now it's going to come in the form of ax plus by equals c. And remember that c right there, that is a constant, okay, a value that will not change in our word problem, okay? So let's go over here and see how we can use it, okay? So the first thing we need to do in step 1 is we need to set up two equations based upon this word problem. Now, looking at this word problem, we need to probably highlight some key things. So it says, you and your sister decide to combine your salary for the week to buy a birthday gift for your mom. How sweet. Your pay rate is 8 per hour, so your pay rate is 8 per hour. And your sister's pay rate, okay, is 10 per hour. The total amount earned was $160. Okay, now that's a big piece of information. The total amount was $160. If you work 2 more hours than your sister, how many hours did each of you work? Okay, and that last bit of information is pretty important. You work 2 more hours than your sister. All right, so let's take all these pieces of information and try to create some equations that will allow us to find the intersection. Okay, so starting with the red part, it says your pay is $8 per hour. Okay, so that rate of change is every hour I get $8. So I'm going to put 8M, and I'm going to say M is equal to you, S is equal to your sister. So that way, if you're curious on what M and S stand for. So if I work 1 hour, I'm going to earn $8. But then your sister is also working, okay, and earning $10 for every hour she works. And your totals combined equal $160, okay? So you're combining both of them. Now, it goes on to say that the total amount earned, okay, it was 160, but it says if you work 2 more hours than your sister, how many hours did each of you work? So it says that the total hours, M, which is, you worked 2 plus S, because it says that you worked 2 more hours than she did, okay? So that right there is going to be our 2 equations, okay? And we're going to get more practice with this by Friday, and we're going to have the ability to really dive into this stuff. So please don't get hung up if this was a struggle at first, because we're going to have plenty of examples and opportunity to practice. Alrighty, so now with these 2 equations, we got to go ahead and use the same process. We need to isolate the variable. Well, guys, guess what? It appears that this one is already isolated. This one I could already plug into the second equation. And I can plug it in where it says M, right? So I have 8 times 2 plus S plus 10S is equal to 160. That right there, that's that blue part, okay? Alrighty. And let me get that color. Good. And so now I'm going to distribute my 8 into the parentheses. So I have 8 times 2. That's going to be 16. 8 times S is going to be 8S. And then I have my 10S equals 160. Okay. Now, I can combine some like terms. I have 16 plus 8 plus 10, that's going to give me 18S equals 160. Now I'm going to go ahead and subtract that 16 to the other side. And if I'm not mistaken, let me bring out my little handy dandy calculator. 160 minus 16 is going to give me 144. Okay. All right, everything checking out. Yeah, looks like everything's checking out. So I've got 18 S equals 144. Now I'm going to have to divide this by 18. Okay, so I'm going to divide by 18, and I get 8. So S is equal to 8. Okay, and that right there is going to be our green part. Okay, we solved for this one. Okay. Now what we're going to do is we're going to take this green part and we're going to plug it into the other, or one of the original equations, okay? Now those original equations, I think the second one is the easiest, because it literally, all it wants us to do is do M equals 2 plus S, and we said S was 8, so M is going to equal 10. So that right there would be that gold part, okay? Alrighty, so it appears that the answer to this question is, how many hours did each of you work? Well, your sister, she worked 8 hours, okay? And let's go ahead and put some units there. She worked 8 hours, and you worked 10 hours, alrighty? And so that right there would be the intersection, okay, for those two equations. Now, if there's any questions you guys have from this video, let me know. But other than that, that's it. Good job, guys.